All right, everyone, the question says determine the number of significant figures in each of the following measurements. So we have 5 problems here, 5 measurements that we want to determine the number of sig figs. We have our sig fig rules off to the right, so we're going to use these to solve these problems. All right, so for question A, we have the measurement 24 milliliters. So how many significant figures are in 24 milliliters? Well, looking at rule number 1, all non-zeros are significant. So we have a 2 and we have a 4, both digits being not 0. So both of those would be significant. So for A, we would have 2 sig figs. All right, question B, 3,001 grams. Well, we know the 3 and the 1 are both going to be significant because, again, rule 1 says all non-zeros are significant. So what about the zeros in between? Well, looking at rule number 2, zeros in between sig figs are significant. So because both of these zeros are in between the 3 and the 1, which we know are significant, they must also be significant. So we're going to have 4 sig figs for the answer to question B. Question C says 0.0320 meters cubed. So the 3 and the 2, we know those are both significant, but what about the zeros to the left and the 0 to the right? Well, looking at rule number 3, zeros to the left of a sig fig are not significant. So this first 0 here and this first 0 here are both not significant. They are not sig figs. They are just placeholders. We have to put them there in order to write the rest of the number. So those are not significant, but what about the 0 to the right? We're going to have to look at rules 4 and 5. So 4 says zeros to the right of a sig fig are not significant if there isn't a decimal point. Well, we have a decimal point. It's right there. So let's look at rule number 5. Zeros to the right of a sig fig are significant if there is a decimal point. So we do have a decimal point. So this 0 being to the right of the 2, which is a significant figure, that being in that spot with the decimal means that it is significant. So here we're going to have 3 sig figs. All right, question D says 6.4 times 10 to the 4th molecules. So the nice thing about this number is it's in scientific notation. We have 6.4 times 10 to the 4th. In scientific notation, whatever digits are written out first must be significant. So we're going to assume that this question was written correctly, and both the 6 and the 4 are significant digits. Now, those both being non-zeros by rule number 1 are significant anyways. But if we had any zeros, like for instance, if we wrote 6.40 times 10 to the 4th molecules, the 6, the 4, and the 0 would all be significant because if that 0 wasn't significant, we wouldn't write it. If we wrote out 6.4 times 10 to the 4th in non-scientific notation, we would get 64,000. So looking at that, we would look at these 3 zeros to the right. Are they significant or not? And rule number 4 would give us the same answer as our number in scientific notation, where any zeros to the right of sig figs are not significant if there isn't a decimal point. So because there's no decimal point right here, these zeros to the right are not significant. So again, we would have for question D, 2 significant figures. All right, last question, 560 kilograms. Well, we know the 5 and we know the 6 are both significant because they're not zeros. So what about that 0 to the right? There is no decimal point, so that would mean that we are looking at rule number 4. Zeros to the right of a significant figure are not significant if there isn't a decimal point. Okay, we did not write a decimal point right there. Okay, there is none. So that 0 is not significant. If we had the number 560 with a decimal point, we would be saying we do know that 0. So we'd have 3 sig figs there. But for just 560 kilograms, that is going to be 2 significant figures. All right, there you have it, determining the number of significant figures in 5 different measurements. All right, if you want to see another example, click in the top right. Please like this video if it helped you in any way. Feel free to look in the doobly-doo below for additional help and resources. Please subscribe and ring the bell to get notified for new videos. And thank you so much for watching.